Hello everyone. In today's example video, we're going to go over some examples of solving systems of equations by graphing. This means that when given two equations, we graph both of them on the same graph, and we find the point where the two lines intersect. The x and y values for that point are our answer. So, let's try our first question over here. Try graphing it by yourself, and we'll go over it now. Okay, so our second equation is already in the y, or really neither equation is in the y is equal to mx plus c form. So we'll rearrange it into this form, the slope-intercept form, so we can graph it easily. And remember, you can use this form, you can use the point-slope formula, either way works, as long as you find a way to graph it. So if we rearrange equation 2, we get x plus 2 is equal to minus 2y, or minus half x plus 1 is equal to y. And that's our y is equal to mx plus c, that's our slope-intercept form. For our first equation, if we move y to the other side, we have 5x plus 6 is equal to minus 8y, and we have 5 over 8 minus 5 over 8x plus, minus 3 over 4 is equal to y. So this is our second equation. Now, we graph both of them. Here's our graph in the xy plane. We take the first equation. Our y-intercept is minus 3 over 4. So we'll start out somewhere around here, and our slope is negative, so the shape of our graph will be downward sloping, and our slope is less than 1, so it's not a very strong slope. Something like this. As for our second graph, this should be minus 1. Our second graph will start at minus 1, which is a little lower than minus 3 over 4 on the y-axis, and it has a slope of negative half, which is a little smaller than the slope for our earlier graph. So it will look something like this, or try drawing that a little neater, like this, where this is line 1, line 2, and line 1. So the point where the two graphs meet is somewhere around here. For the x and y values at our point, P, equation 1 and equation 2 are satisfied. So, and that should be minus 1. Let's try another example. Here we have three equations. X plus y is equal to 3, 2x minus 3y is equal to 4, and x is equal to 3. Let's actually change this to 6 and try solving this based on what we've learned already. Remember, when you solve by graphing, you have to graph all three equations on the plane, and you have to find the point where the lines intersect. We'll go over that now. Alright, for our first equation, when we turn it into slope-intercept form, we have x minus 3 is equal to minus y, or minus x plus 3 is equal to y. For our second equation, we have 2x minus 6 is equal to 3y, 2 over 3x minus 2 is equal to y. And that's our second equation that we can graph. And for our third, we're done. We can't do anything more. So, let's try graphing these. Minus x plus 3, our y-intercept is 3, so that will be here. Our slope is minus 1, so our line will slope downwards. For our second equation, 2 over third x minus 2 is equal to y. The y-intercept is minus 2. And minus 2 will be a little closer. And the slope is 2/3, which is positive. So it will look something like this. We know that it crosses at exactly this point on the x-axis because if we substitute y is equal to 0, we have 2/3 x minus 2 is equal to 0, 2/3 x is equal to 2, x is equal to 3. And we'll get that same answer for the first equation. If x is equal to 3, then we have minus 3 plus 3 is equal to 0, which satisfies our equation for when y is equal to 0. Now, our third line, x is equal to 3. This is a straight vertical line parallel to the y-axis going through the point 0, 3. So we see the solution to our system of equations is the point 0, 3, the point where all three lines intersect. Now, you're probably wondering, what happens if all three lines don't perfectly intersect at the same point? What if they look something like this, where two of the lines are parallel and will never meet? Or what if they look like this, where all three of the lines are parallel and never meet? So, in our next lessons, we're going to learn how to handle systems like that. Now, recap, solving by graphing. You can take any number of equations, you graph them on the xy plane, and you find the point where they intersect. And that's your answer.